First off, why are we considering doing a 24-hour analysis instead of just peak hour analysis? And when we kind of look at the daily volumes throughout the day, instead of just capturing kind of that 8 to 12% for our highest peak, or 15 to 30% of the delay depending on the location of the intersection, and then crashes, bringing safety into the equation. When are those crashes usually happening? Usually they correlate with when there's higher congestion and higher volume. But when you start looking at when crashes are happening throughout the day in the figure in the top right, it really is a small percentage of the daily safety risk as well. So by taking advantage of a daily analysis, we can really look at what the overall delay per person or delay per vehicle metric is out of VISSIM, and try to really get a good understanding of what the daily benefits could be of different alternatives that we're looking at. So for this presentation, I picked out two different locations where we had a couple different studies. The first one was up in International Falls, so on the border of Minnesota and Canada. It's a very rural location just outside of the main city, and there's definitely a recreational peak along the state highway. And we're really looking at a roundabout versus an RCI, and having to deal with a lot of truck traffic going through the intersection. And then the other example I brought up is more of a corridor study in an urban environment. We're looking at a 4 to 3 lane conversion in Minneapolis, Minnesota, and really looking at the urban and multimodal use of the corridor with our different alternatives. And by converting to a 3-lane corridor, we had a lot more space for bikes and peds along this higher volume urban corridor. So starting out, we really want to take advantage of any raw data we can get for a project. And so more data equals more validation, more ways to feel comfortable with the alternatives that you're analyzing are really addressing the traffic conditions that are out there. So when we start off with a project, we're usually collecting turning movement counts. We're collecting any past average daily traffic or AADT numbers. When MnDOT has an ATR site nearby, we'll take advantage of that so we can really look at that continuous stream of traffic volumes using one of the roadways. But then having an idea of the events, recreational traffic, and truck considerations at the intersection is always a good, important factor to consider as well. And so for our International Falls study, this was a major intersection where logging trucks were crossing the major roadway. And so although the traffic volumes are relatively small, having to come to a complete stop for these logging trucks that were 90, 100 feet long, and then having to accelerate across the intersection while sight distance to the north was limited, and it was a recreational corridor with 60-mile-an-hour vehicles coming southbound. It was a very high safety risk, even though the existing crash history wasn't exactly tracking that way. And so we had to use a lot of different data to really quantify the need at this intersection. And so one of those tools was StreetLight, and we really used it as a seasonal evaluation of how traffic volumes were changing between the different months of the year. And so we pulled 12 months of data between 2019 all the way up to 2021. And we really used this to show how those volumes were changing throughout the year and how the distribution of traffic was changing as well. So those logging trucks, commercial WB62 trucks, we kind of looked at both sets of data out of StreetLight and kind of compared that to our raw data, and we found how those different trucks and kind of total volumes were changing between January, when there were a lot more logging trucks at the intersection, versus July, when there was a lot less logging trucks and more personal type vehicles. And so we can also use StreetLight data to kind of manipulate it down to, almost a daily level if you're able to pull kind of 52 weekly analysis in a year and then divide it out by Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. You can almost look at a daily level too. So the strength of StreetLight data is in kind of the averages of the data, but really kind of seeing how some of that data is kind of going up and down on a daily level too can be really important to certain projects. And then lastly, for our Lowry Avenue study in Minneapolis, the big question was, how was traffic responding due to COVID? Can we quantify what that drop is? Can we quantify if it's recovered? And then kind of looking as we came into 2021, we really hadn't recovered. It was a major kind of arterial corridor, but it was still right on the edge of downtown. So we weren't seeing those pre-pandemic volumes that we were expecting. And a lot of the stakeholders are feeling a lot more comfortable at having a 3-lane section through here because of those depressed volumes. And so when we start looking at implementing this into our 24-hour analysis in VISSIM, we're really breaking it down by intersection. We're breaking it down by kind of that hourly volume throughout the day. And then we're really filling in the holes where we don't have raw data. And so for this example, we had a number of different intersections on Lowry Avenue in Minneapolis where we had kind of some raw turning movement counts. We were able to validate those against StreetLight volumes as well. But where we were kind of missing those turning movement counts throughout the day, we were able to kind of paste in the StreetLight counts and then really look at the validation versus those daily volumes that we knew were out there, that we knew kind of were those average values, and identify some of those different approaches that might have been low or high comparatively, and then factor them up to better match those average daily traffic volumes. So we're still getting that origin destination or turning movement percentages from StreetLight, but we're really able to match the volumes that we're expecting out on that corridor. This was especially important for another study in Minnesota, but I wanted to bring it into this presentation, where we were considering bypasses for a roundabout because we had very high daily volumes for a couple of different movements, and they were specifically the westbound right and southbound left vehicles or movements. And we were using turning movement counts from 2017. And when we started looking at kind of the monthly data of StreetLight versus our raw turning movement counts, we were able to identify that our previous counts back on kind of from 2017 were mostly caused by a bridge closure that was happening, and that happened again in 2019 as well, that was forcing more traffic to this route. So when we started running our VISSIM models, our alternatives analysis using that previous collected data was telling us something completely different than kind of a possibly downsized roundabout that more balanced the turning movements at the intersection. Another big thing that we've used StreetLight data for is implementing peak hour factor when we don't have the turning movements to do that. And so we'll implement this throughout the day using kind of those 15-minute increments and then taking those hourly volumes from our static routes in VISSIM and really applying just the peak hour factor to the inputs. And so we're able to kind of match that peak hour factor across those 15-minute periods while still having kind of those balanced hourly volumes for our static routes. And then another big advantage of using StreetLight data on this corridor study, as we were starting to look at reduction of access for some of these roadways, we were able to look at the origin destinations of specific through trips on some of these minor approaches. And we found a lot of zigzagging traffic where they'd really look at avoiding some of the major intersections. So this is University Avenue and Lowry Avenue, two probably 20,000 plus AADT roadways, where traffic would kind of snake around these big intersections that had a lot of congestion in the peaks. And so we were able to identify kind of some latent traffic demand and then identify some of those parallel routes that we could take advantage of if we did implement some access restriction along the corridor. And then we used StreetLight top routes to get that information, and we've used it on several different projects in a similar way. So just getting into kind of the 24-hour result benefits, we're able to really look in VISSIM at both the average daily travel times and the 85th percentile travel times, and really compare that back to StreetLight data as kind of a validation step for existing conditions, but then have some of those travel time increases when we were considering the 4 to 3 lane conversion. And then really look at delay throughout the day. So we were talking about how AM, PM, school peak hour delay are really small percentages of the total delay along the corridor when you're looking at it from a daily level. And then lastly, we really used benefit cost analysis to justify some of these improvements, adding them to the project. And so this is the Koochiching County example where up in International Falls, where we were putting a roundabout in at an intersection that didn't necessarily need it from a traffic volume standpoint, but we were able to really combine the 24-hour results, show that there were advantages throughout the day, and really combine safety measures into it as well, using a conflict analysis with SSAM to provide kind of a proactive BCA to the client and help to get this roundabout approved. We really have found a lot of benefits from using a daily analysis, and StreetLight really gives us the tools to take some of those pieces of the traffic volumes and really combine them into a 24-hour model that we can get those advantages when we're doing more of a detailed site-specific analysis. And so it's better to identify daily solutions that are benefiting all users and not just the commuters in the AM and PM peak hours.